buat minggu depan. Hello? Atau minggu yang ujung sekali, minggu 14. Okey ke macam mana nak buat bila tu?
Doktor, minggu 14 boleh?
Okey, kita buat minggu 14 lah macam tu.
Terima kasih, Doktor.
Okey, kita buat time yang sama lah. So ada 1 minggu lagi next week untuk review. Okey, kemudian satu lagi yang saya tengok ialah mengenai makmal. Okay, sorry. I have to speak in English. Okay, one more thing that we need to consider is lab test. Up to now, I don't know how is the progress, because last time we don't allow a student to enter the labs due to COVID-19, and I don't know whether anybody or any group ever done any lab test yet. I don't know about that. Maybe I need to ask
Doktor.
Tak benar? Okay.
Macam mana ni, Doktor?
Okay, so in that case, then the simplest and quickest way is that I give the data, and then you will do it. There are only 3 lab tests: consolidation, direct shear, and also triaxial, if I'm not mistaken. So there are only 3 tests, and I think you can share among your group members to do which test, so every group need to come up with 3 reports, which is for test 1, test 2, and also the lab test 3. So then I think you can just distribute the workload among your group members. Then it will be much easier for you. Okay, then I hope by tomorrow, I hope maybe a day after that, I'll give you upload you the data, because I need to check with the lab first whether they have data. If not, we can just use the problem in the textbook. There are some data then, and then you come up with the reports. If they do have the data, recorded data previously done by them, then we can just use the data. Okay, by tomorrow, hopefully I be able to upload the data, and then you can start working on the lab reports. So each group need to submit 3 reports for the 3 lab tests. Okay, that is for the lab test. And for the test number 3, which going to deals with chapter 13 and 16. Two chapter 13 and 16. Then for the assignment, I already post on the Facebook group, and also I already create the assignment in the UKM folio. So if you happen to finish them, then you can upload the assignments there. There is an individual assignments. Okay, that is for the assignment. And for the teaching part, yeah, I already upload also in the Facebook group. But today we, for those especially who already look at the chapter 13 and 16, and also for those who already look at the problems or assignment, you may have question, then you can ask during this meeting. If not, we just going to go over very quickly so that we have some idea. In the past, I used to have the PowerPoint, but I don't think it is any helpful since we go over the PDF file, much easier, especially for you when you want to do the test. You get familiar with the material itself instead of totally a new one. So that's why I prefer to use straight to the textbook PDF, so you know which material we covered and which one we skipped. So it will save your time and also easy for you to go over your textbook, the PDF file. Okay. Is there any question from you regarding the two topics, the chapter 13 and also 16? Chapter 13, okay, I think I should share the screen. Okay. Okay, can you see the screen?
Ya, doktor.
Okay.
Yes, Doctor.
Okay. Is it clear or you need to zoom a little bit?
Okay, Doctor.
Okay, okay. Okay, the topic or chapter 13, we are dealing with the lateral earth pressure. Lateral earth pressure. So we actually need to calculate the pressure on the retaining wall, or lateral earth pressure, or horizontal earth pressure. Okay, so there are three concepts, which is they call it at rest, Rankine, and also Coulomb concept. Okay, so now imagine that you want to create a retaining wall. So you're gonna have the wall itself. For example, okay, like this one. This is a retaining wall. So, okay, let me see whether I can get the highlight or not. Okay. So, okay, let's say this is a retaining wall. And definitely you are going to design. Let's say you have a slope. Normally we create retaining wall at slope. Let's say we have a slope. And then we want to create a retaining wall like this one. So we need either to fill this area, let's say the slope, something like this one. So we need to fill this side and create a retaining wall. Or sometime we have the existing line is like this one. So we have to cut the ground and create a retaining wall. So there are basically two methods of construction. So let's say we decided to create a retaining wall, and now we want to start, since we learn the concrete design, let's say we want to have a concrete retaining wall, or even we can have a steel retaining wall. Doesn't matter. Actually, there are many types of retaining wall. Modular retaining wall, cantilever retaining wall, gravity retaining wall, and so on. I think that is in the next chapter. I think in or the previous chapter. But it's okay. Any retaining wall, the first thing we need to know what is the forces on the wall due to the soil behind it. Because definitely, excuse me, definitely when there is a soil behind it and the wall to function as a retaining structure to retain the soil, so the wall will experience lateral or horizontal forces due to the soil. So let's say in this case, for example, we said there are three, I would say, conditions. When we decide to design the wall, there are three conditions. One is at rest. We assume the wall is going to perform straight. It is perfectly straight like this one, not moving to the left or to the right. So in that case, let's say we were to design a wall that is at rest, meaning that not moving any direction. So that condition we call it at rest. And then for the active case, we assume the wall, when we design it, we want to make the wall move a little bit to the left side here, out of the soil. So to the left, with a certain displacement or deflections. And that design we considered as an active case. And then the last one, the passive case, is when we design the wall, we want to make the wall or push to the right of the soil. Then we need additional force from the soil. Since the wall itself is pushing to the right, the soil need to have a greater forces, greater force or pressure, so that the wall is in the shape like this one, in the passive shape. So there are three cases here. If we look at the cases when we want to decide, for example, when we want to have the at rest, when we want to have the passive case, and when we want to have the active case. So the decision before we decide is that we need to know. Let's say we want to have a stronger wall. The strongest would be the wall in the passive pressure, because when we design, we assume it is pushing to the right, and the forces or the pressure from the soil on the wall much higher. So this is the very conservative design. And then maybe we want to ask, why on earth we want to have this kind of wall? It is like slanting to the right, not to the left or straight. So normally we design this kind of wall, for example, for jetty, where we have here this area maybe the sea water, and there are boats or maybe ships that sometimes hit the wall. So that's why they make the wall much stronger than the normal case. So that would be one of the application. And then for at rest, for example, like this one, why we want to make it straight? And normally this one, when we think that the wall may cause danger to people, maybe people that move below the wall in the city area, maybe we design at rest condition. But most of the time, normally the wall is quite far from people, not the access area. Let's say this is for at rest. Normally, maybe there is a road next to it. But if not really critical, it's not going to hurt people if it collapses. Then to be economical, then we design in the active pressure case. Something like this. The wall, we make it move to the left. And how far we are going to move the wall? Normally, there is depend on the height of the wall. I think here they should give you roughly here. For example, okay, here typical value. It gives here what is the typical value of displacement over height of the wall. And also it depends on the type of soil. For example, loose sand, the ratio, which is 0.01 until 0.02 and so on. So this table can be used to decide what is the displacement we allow for the wall to move. Okay, so that is the three condition. So if you were to imagine simple, at rest, it is like when we are not hungry, we are just steady. So our tummy will be just flat like this one. But this one, active pressure, our tummy a little bit move forward because we just eat. So that is active case. And this one, let's say we don't eat for 3 days, for example. Our tummy is concave to the right, very hungry. This is in normal condition. At rest, active pressure, we are full. We are full. Our tummy are big now. So in that case, which one is economical if you were to invite these, let's say, people to eat? Definitely, people who is full is cheap, eat little. And then for at rest, you can eat maybe 1 or 2 plate. But for the passive pressure, you're gonna have to spend a lot of money, because he's hungry. So that is the condition to see which one is economy or which one is not economical. So most of the time, the engineer design the active pressure case, because we want to achieve economy, use less money. Okay, so based on that 3 conditions, then we can start do the design or the calculation. The idea is actually we just want to know what is the lateral pressure from the soil to the wall so that we can design the wall. If you are taking or have taken a concrete design courses, then you need to know that we need to provide the pressure or the forces that is applied on the concrete. So to design the concrete, we need to know what is the lateral pressure applied to it due to the soil behind it. So that the whole topic is about how to calculate the lateral pressure that the soil gives to the wall so that we can design the wall. Okay, after the pressure, definitely we want to know the out of the pressure, what is the force applied on the wall. Okay, the concept that we need to know is K value. Okay, K is actually is a ratio between horizontal pressure or stress over vertical stress. So actually we want to calculate the horizontal stress here. So horizontal stress then equal to K times overburden stress or overburden pressure, which is vertical stress. Normally, by this time, we should know how to calculate the vertical stresses. For example, this point. To calculate the vertical stress, we need to know what is the length or the height from the ground level here to that location. What is the height? Then you multiply it with unit weight of soil. So that is how to calculate vertical stresses. So it's easy to calculate vertical stresses if we know the height and we know the unit weight of the soil, either dry or saturated. So vertical stress we can calculate, and K, whether K naught for at rest, Kp for passive, Ka for active case, that one we can calculate or look at the table. So it's easy then. So we know the vertical stress, we can get the K value, so we can calculate the lateral or horizontal pressure or stress. So this equation is 13.2 is a general equation that can be applied to all the three cases, except the equation for the K, not Kp and Ka, a little bit different. So you need to know first, you need to know whether you want to design active case, passive case, or at rest. Then you need to know how or the equation for active, what is the equation K value? For passive, what is the equation for the passive case, and so on. So it is just a matter of finding or using the right equation to calculate the lateral earth pressure or lateral or horizontal stress. Okay, so the whole chapter is about using that equation. So okay, now we look at, for example, the at rest, for example. At rest, the K value is 1 minus sigma 5 5, effective 5. This is the equation that you're gonna use. So you're gonna use this equation, and here it also mentioned that for dense and loose sand, for example, you use this equation. So you just need to know which equation of K to use. Okay. And then this one, if they is about over consolidated soil or backfill, then they normally we need to know what is the OCR, over consolidation ratio. Normally, if given, if the question, if you need to use this one, normally the question tell you that it is a over consolidated clay, the OCR value is this and that. Okay, so then you know you need to use equation 13.7 and so on. This K, what is the K naught for over consolidated normally using this equation. Okay. So, and we also know normally for pressure in soil, it is the horizontal stress greater when we go deeper and deeper. For example, from the soil here, top level, if you want to calculate the soil at maybe the middle of the height here, the value of horizontal stress is like this one. But if we go deeper, let's say until the height of wall, so the value of horizontal stress or lateral pressure become greater. That is common sense. Actually, we can prove it by calculate the vertical stress. Because in the case here, K is constant and vertical stress is increasing because the more load on the top, the more vertical stress and so on. So to calculate the horizontal pressure here, it is just K value time the vertical stress, which can be calculated easily. Okay, here is about earth pressure at rest for partially submerged soil. When there is a water, let's say the wall is submerged in water. So for example, like this one. Okay, so the groundwater table is up here. So we need to consider the effects of water pressure. So normally if there is no water pressure or groundwater level here, the distribution lateral earth is just straight line, maybe A to C. But due to the water here, so we have something like this one, not straight line. Which is due to the U or pore water pressure. Pore water pressure is actually the unit weight of water times the height of the water. So you get it. So you can easily calculate. I think in the previous chapter also we deal with how to calculate the effective stress. When there is water, how to calculate the effective stress. The same thing. Because that is the vertical stresses. When we know vertical stress, we know the K value, then we can easily calculate the lateral pressure, which is horizontal stress. Okay, so this is just a combination of these two. This one due to the, okay, this part is about dry unit weight of the soil. And this part due to the saturated unit of weight of soil, and this is due to the existing of water, which is pore water pressure. And then we need to combine these two, so we get pressure distribution, something like this. Okay, since we know that water pressure diagram here, we can easily calculate the force due to the pressure. Okay, so to calculate it, we know that, for example, this case, for this upper part, the force is 1/3 from the bottom here, the location, and the value is just the area of the pressure diagram here. And the same thing also for this part, we can make it a two-part here, rectangle. So rectangle, the location of forces is half of the height here. So we know it is at the middle here. And the value for the force is actually the area of this pressure diagram. And we can do also for this triangle, the location is 1/3 of the height here, below here. And then we calculate the area of the pressure diagram, then we know the value for that. The same thing like this one. So at the end we can get a force. We can get force and not a force. Forces. We have many forces. And at the end we're going to make it like a one single force that resists the forces. So it is like this one. So we can calculate. You can look at the example 13.1. Yeah, I think I tried to speed because they should be in the lecture teaching video. This actually for today, I just would like to go over quickly, so that you can ask the question if you're not sure. Okay, so this is how to calculate. For force, is about the area of pressure diagram 1, 2, 3, and 4. So in this case, I think maybe they are referring to this one. This area, the triangle, and also the triangle. So at the end, you can calculate the total P. What is the total forces that is applied, that the soil apply to the wall. Okay. And the same this one with the groundwater table. Okay. I think if you look, read carefully the sample, the example, it won't be any problem for you to understand. Okay. Next we go for active pressure. Remember just now we are talking about at rest. And now it is the active pressure ranking theory. So here we have another two theory, which is Rankine and Coulomb theory. The difference between the two is that Rankine consider the wall here and the soil behind it no friction, meaning that there is no contact or no friction between soil and the wall. So the calculation becomes simple. That is Rankine. So for Coulomb, it is using, it consider the friction between the soil and the wall here. So the calculation of that theory is more complicated. And when the calculation complicated, the equation we get from the Rankine theory is a little bit longer than the Rankine. Okay, for active pressure, since we say active, the wall will move to the left here. To the left here, so it is like bending. The wall profile will move to the left with a certain amount. So if we look at the pressure diagram, so it's become like this one, because that the wall moves to the left, so there is a pressure also become like this one. The diagrams. Okay. And then we need to also know whether the soil is granular, which is sand, or whether it is cohesive, which is clay. So clay and granular material, then the equation for K may be different. So you need to consider now when we want to design one at the soil condition, whether at rest, active and passive, and also the type of soil, whether it is sand or clay, whether over consolidated or not over consolidated, whether there is the groundwater table or no water ground table. So then you need also to consider whether it is using the Rankine theory or whether it is using the column theory. Then from all those different combinations there, from that you need to know which one is which one. At the end, you need to pick up which K equation is the right one. So your task is actually not very difficult. You just need to know if it is Rankine, you use the Rankine equation factor or not. If you say for clay, then you find the clay in the Rankine. If you say it is groundwater table inside that, then you need to consider pore water pressure. So what else? So those are the things that you need to consider before you choose the right K value equations. Okay. Okay, then this is the, for example, Ka. For the active K Rankine method, the equation is like this one. Tangent squared 45 minus effective phi over 2. So this is the equation. If you want to design for active case, this is the equation that you're going to need to use for K. And then you can use the other equation. Okay. And this one is for the theory of passive, Rankine passive pressure. So for passive case, which the wall moves to the right. So use this equation. Okay, so I'm going to go very quickly. So this is the Kp, or the coefficient of Rankine passive earth pressure. This is tangent square 45 plus instead of minus. So this is for Kp. For active, 45 minus. Okay. And then on top of that, you also need to know whether the wall has sloping or not. For example, this is the slope. And normally there is a flat roof or top here, but when your wall have a sloping angle here, and then you need to find what is the equation now for it, because it's a different equation for Ka. So now it's a little bit more complicated because there is a sloping slope on top of the wall. Or you can use this handy dandy table to find what is the value of Kp, for example, or you can use the equation here. But the equation can be sometimes can be difficult for you to calculate using calculator, normal calculator. So the easiest way is to use the table. For example, table 13.3. You know the angle or sloping angle. you know the phi value, and then you can get from table the Kp value. So you don't need to use this equation to calculate. Okay. And this is the diagram. Normally the diagram is like this one. Okay. When there is a groundwater table, so it become more complicated. And when there is surcharge, meaning that maybe there is a building on top of the retaining wall. So it is also making your calculation complicated, but actually it does affect on your vertical stresses. So here we have like this one. Surcharge kilonewton per meter times Ka. That is the value. And then we have groundwater table here. That is why we have a different shape. It's not a straight line from top to down. So we have a different shape. So this is due to the groundwater table. So you can look at this one. Actually, if you understand it, it's easy to understand why this term and that term. Because they need to consider the groundwater table. Okay. And also the pore water pressure in the calculation. Okay. Okay, for active case, let's say this is the wall. This is the passive case. To the right is passive case, and there is a surcharge. So the pressure diagram become more or less like this one. Actually, it's similar concept. Okay, and sometimes when we want to design the retaining wall, we need also, since let's say it moves to the left. Let's say the wall moves to, after construction, the wall start moving to the left, to this direction. What happened to the soil is that behind the wall, maybe few meter behind it, there will be a crack because the wall moved to the left and the soil crack here. We can see the opening. If we at the side, we can see there is an opening there because the soil fail. Because the wall moved to the left, the soil will be cracked. So the length of the crack can be calculated using this equation. Okay. And to understand better, you can look at the example 13.2. It gives you a straightforward sample problem. And also 13.13. Okay. And the rest, if you look, actually it's a straightforward, not difficult to understand. And then after that, we look at the at rest, passive case, active case, cover consolidated, groundwater table effects, and then the ranking one, and now at the sloping slope, the wall with sloping slope. So many different types. And then now we look at the column pressure. Column consider the friction between soil and the wall, so it become more complicated, the equation. The equation becomes more complicated. So as we can see here, for active earth pressure, Ka for column the equation is lengthy. So we have like this question, and to calculate it, maybe after you calculate it, you get the wrong answer. Your calculation is not right. So the easiest way is to look at the table given to calculate the Ka. And knowing the alpha, slope angle, and also the phi value, and also the angle here. So the angle here is, we need to look at the figure here. So here is the beta here. This is the phi value. This is the alpha value. And this is the theta, the value. So we need to use those value and put it in the equation, or we can just look at the table to find the coefficient of active pressure. So the idea is actually to find the K value. When you get the right equation, you calculate the overburden pressure or the vertical stresses. For lateral pressure, you just multiply the two parameters and you get it. Okay. Graphic solution, you don't need to look at this one because we don't easier if you use the table. Okay. This is the way how to do the column method. I think you can, for column, you just need to use the table. Don't need to do the graphical method. That is beyond our scope. And then we look at the column passive pressure. Just now is about active pressure, and now about passive pressure. So the equation Kp is given here, which is also long. So we need to use the table. So, okay. So the rest, I would see there is not much. And then a type of retaining wall. Yeah, that at the beginning I mentioned about the type of retaining wall. Here we do have the type of retaining wall: gravity wall, semi-gravity, cantilever, counter force, and so on. We can look. I think there should be a picture here. Gravity wall is like this one, no reinforcement inside, so it depends on the weight of the concrete. Semi-gravity by putting the reinforcement. Cantilever here, because here they call it cantilever here. So with a reinforcement become cantilever. And this is the counter force wall. Yeah, this is a sample of cantilever wall. So the wall here, I think behind it there is a cantilever. Cantilever in bahasa is terjulur. So when there is something, the beam terjulur or cantilevered, we call it cantilevered. And this one, this is relatively a new concept. In retaining wall, they call it MSE, mechanically stabilized earth. Sometimes they call it reinforced earth, because we know that the soil behave like concrete, which is weak in tension, strong in compression. So when we want to use the tension, then we need to put reinforcement here. So that is why the soil is reinforced, or we call it mechanically stabilize earth wall. So the earth is reinforced. So if we look outside, maybe the highway north-south highway, then you can see a lot of a returning wall using the reinforcement or the MSE wall. If you look at, let's say, when there is a flyover, you see the block of concrete. They arrange it in a nice way. So you see concrete blocks. The wall is concrete block. Normally behind it there is a steel reinforcement. If they use granular material like sand as a backfill, but sometimes they use geotech style or geogrid instead of the steel reinforcement. And sometimes the gabion also, the gabion is, if you want to know the gabion, sometimes you see a rock like in a steel mesh. That is a gabion wall. It is a gravity wall, but now to reduce the size of the wall, they use the reinforcement behind it. So you see here, they may use the geogrid or geotech style or even steel. So this is the concept of MSE wall, mechanically stabilized earth wall. Okay, so that will be the end of chapter. This picture show the geotextile or geogrid laying behind the wall here. So normally the construction is from top to bottom. So nothing here. Now they want to create a retaining wall. So what they did, they compact the soil and then at certain level and they apply the geogrid here. Some part of the geogrid is under the wall, meaning that this is a segment, many segment. So the wall here lock the geogrid or the geotextile here, and then they pour the sand, the soil, they compact again at the same at the different level, higher level, and then they lay another layer of geogrid, and then they compact again, they put the soil and then compact, then put another layer, and it goes on until to the height of the wall that they required. Okay, so that would be the end for the chapter 13, which is lateral earth pressure. So you need to do the assignment for that. And then I think for the next chapter, we discuss it next week. Yeah, maybe that is for today. So next week, we still have another class. And then a week after next week, we're going to have the test number 3. So, yeah, okay then. Okay, is there any question? Okay, any question for that chapter?
Tak ada, Doktor.
Okay, tak ada.
Tak ada.
Okay. I think sometimes it's better we have like a forum. Then I not only I can speak to somebody because now it seems all immune, so it's slow. Maybe one or two, assign one or two from you to always on the mic and become like a panel. Then it will be easier, more lively then. Okay, no question now, up to now. Is there anybody want to ask or discuss or anything from that chapter? Okay, Luqman Hakim, yeah. I think it is not on the mic.
Sorry doktor, saya tertekan. Sorry.
Okay. Okay, anybody want to ask question? If not, we can just dismiss. Then you can start working on your assignment.
Doktor, tadi attendant tadi ada yang tak dapat nak sign in.
Okay, tak apa. After this, I will show the attendant back. Okay, ada lagi?
Doctor, the due date for the assignment, chapter 13 and 16, is the same that listed in the UKM folio, Wednesday 14th of July.
Okay, for the assignment, I'm not so worried about the date because as long as you submit during the semester, just now I just put the date until 14. Until the end of semester.
So the e-test 3, when the date?
That one is I will a week after next week, meaning that 2 weeks from now, in the 14 weeks, the last week. Yeah, we have just decided the date. I haven't put it in the UKM folio yet, but it's 2 weeks from now.
Okay, Doctor.
Okay, any other question?
Boleh saya tahu chapter berapa yang masuk? Saya terlepas tadi.
Hello? Tak dengar tadi ya?
Dia tak sengaja on mic ke?
Oh, tak sengaja on. Okay. So, in that case, nanti saya tengok, saya refresh balik attendance.
Doktor, saya ada soalan.
Okay.
Tadi kan doktor masa awal tadi terangkan pasal lab report kan. So memang satu group just hantar satu lab report saja kan?
Ya, ya.
Lepas tu benda-benda yang dalam lab report tu apa benda yang kena ada?
Okay, lab report selalunya ada, saya tak bagi guideline tapi selalunya yang ada adalah ada introduction dia, ada prosedur dia, mungkin secara ringkas. Kalau nak go step by step memang banyak cerita lah. Kemudian ada result and then ada analysis, calculation yang digunakan, dan you punya keputusan dia dan kesimpulan dia. I think that's it lah for the report.
Okay, maksudnya yang first kena ada intro, prosedur, kena ada result, lepas tu analisis daripada result tu ke doktor?
Ya, ya.
Lepas tu last tu dia punya conclusion je lah kan?
Ya, ya, ya.
Thank you, Doktor.
Okey, sama. Okey. So kalau tak ada apa lagi kita boleh dismiss Okey, kita jumpa lagi next week untuk last chapter 16. Actually there are other chapter if I'm not mistaken about other topic, but that one we don't really discuss. Is not in the test 3, and you will learn it in your what they call it, something there is another course specific for that. I think it's about surface, something like that. Okay, if not, then you can dismiss.
Thank you, Doktor.
Okay,
Thank you, Doktor.
so I leave this one for another 10 minutes.
Thank you, Doktor.
Okay, sama.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Okay, sama.
Thank you, Doktor.
Okay, sama. Sini.